Reactive programming in JavaScript results in performance software. Before we look at reactive programming, let's identify the pulling issues in general programming. Pulling is when software executes on a fixed or a variable interval looking for an already occurred event. Let's imagine that you have to wake up at 4 a.m. in order to make it to your flight at the airport. To do so, you must wake up often to check the clock and see whether it's time to leave. An inherent problem with pulling software is that it needs to check for an event whether it's occurred or not. This is an execution cycle that your software pays for, even if there is no occurrence of such event of interest. In this case, you'd be checking the clock often. Therefore, you'd be tired and may miss your flight altogether. Now let's look at reactive programming. Reactive programming is also known as event-driven programming. Instead of pulling for an event on an interval, we simply subscribe to an event and will be notified when such event occurs. Let's look at our example one more time. We need to leave for the airport at 4 a.m. and we'd like to get a good night's sleep prior to our departure. Let's pick up an alarm clock from the store, set the alarm to 4 a.m. and go to sleep, knowing that we'll be notified exactly at 4 a.m. In reactive programming, your code remains dormant till an event of interest has occurred. This results in performance software that is real-time and very responsive. Now that we know the benefits of reactive programming, let's examine it in JavaScript. RxJS is a reactive extension of JavaScript that enables reactive programming by introducing observables. Observables bring together data stream producers and the observant subscribers. Observables can be seen as the glue that sits between the data stream producers and the subscribers. A producer is a data source that emits values. A subscriber is an entity that consumes those values, and the observable facilitates the push mechanism to get the values to the subscriber as soon as they are emitted. There are two types of observables, hot and cold. A hot observable wraps an already existing producer and makes its data stream available to many subscribers. Therefore, hot observables are considered multicast. In this example, the river is an existing producer water stream, the house is a subscriber to that water stream, and the piping in the house that facilitates bringing the water from the river to the house is the observable. Therefore, the observable here is a hot observable. Since the producer, the water stream, is outside the house, as the water stream will be flowing whether there is a house there or not. Let's look at a real hot observable example. The keyboard event could be subscribed to by one or more subscribers. The keyboard event will fire away even if there are no subscribers, as it is outside the observable. A cold observable, on the other hand, is responsible for creating its own internal producer, one producer for one subscriber. Therefore, a cold observable is considered to be unicast. In the following example, there is no river nearby. Therefore, every house needs its own water well. One well to produce water stream for each subscriber house. Let's look at a real cold observable example. The range function in RxJS creates an observable, and each subscriber gets its own internal data producer. Now that we know all about observables, let's examine observables' true value proposition. What makes observable great is the combination of its async nature and its canceling capabilities. JavaScript's inherent async nature via callbacks were not enough. Promises and async awaits were introduced to enhance the experience. However, they are not cancelable either. Let's look at a real example. Callbacks, promises, async awaits, and observables are equal. If your component makes an API call and is still around when the response to that call comes back. However, if the component that made the API call is destroyed prior to receiving its response, there is no way for the component to cancel the call upon destruction unless the component used an observable. Imagine you open a search tab in your application, make a request to a slow server that takes 10 seconds to respond, but 5 seconds into the wait, you change your mind and close the tab. The component responsible for that tab is destroyed and handed over to JavaScript's internal garbage collections. So far, so good. Wait a minute. There's an outstanding response, and that will make it back to the destroyed component, which is no longer in scope. This might cause an out-of-scope execution, and if the tab still has a reference to the application state, it might corrupt the state as well. The garbage collection may not be able to clean the destroyed component either, as there is an outstanding reference to that component object from the request. Therefore, use reactive programming and observables to create event-driven, real-time and performant software. Always unsubscribe from your observables when the component is destroyed or your code goes out of context. Remember, double unsubscribing has no impactful penalties, but not subscribing could have devastating effect for your software. Remember, reactive programming is a mindset. Open your mind to it, and everything will fall into its right place. Let's do a recap of what we've learned. Observables bring producers and observers together. Observables with external producer are considered hot. Observable with internal producer are considered cold. Hot observables are multicast. Cold observables are unicast. Reactive programming is a pattern that enables propagation of change via data streams. Hence, everything is treated as streams. Example includes static array, dynamic event, etc. Reactive patterns promote async push mechanism instead of continuous pulls via function calls. Async push allows for a set of logic to remain dormant till an actionable event is raised. This is a prerequisite to reactive programming and performant software development. Actionable events can be filtered against a set of conditions to only trigger necessary reactions. Bottom line is that reactive programming treats everything as streams. Sub if you liked the video, share with others if you loved it.